Hi there, welcome to Mastering Object-Oriented Programming with Python. I'm so excited to have you here. In this course, we will deep dive into object-oriented programming, also known as OPP, and how it can help you write cleaner, more organized, and scalable code in Python. First thing first, let's answer the questions. What is object-oriented programming? Simply put, OPP is a way of structuring your code so it mirrors the real world. Instead of writing your entire program as one long list of instructions, you break it down into a smaller, reusable components called it classes and object. For example, think about a car in real life. A car has attributes like its color, brand, and speed. It also has behaviors like starting, accelerating, or stopping. In OPP, we can represent this car as a class. At each car we create, say, a Toyota or a BMW car becomes an object of that class. So why is OPP so essential in programming? Well, imagine you are building a large application like an e-commerce website or a game. Without OPP, your code quickly became messy and hard to maintain. OPP helps you reuse code, write it once, use it multiple times, scale easily so that you can add new feature without breaking existing ones. Solve real-world programs. By modeling real-world objects and their relationships, OPP help you build programs that can easily understandable and extendable. Most modern software we use every day, from Instagram to YouTube or Python frameworks like Django, relies on OPP principle. By mastering OPP, you will not only improve your coding skill but also open doors to existing career opportunity. In this course, we will start by building a strong foundation. We will cover core OPP concepts like classes, objects, inheritance, polymorphism. Then we will work on real-world projects like building a library management system. By end, we will be equipped to design and implement a scalable and maintainable application. Alright, that's your quick introduction to this course. Let's move on and refresh your Python basics before diving into OPP. Before we dive into object-oriented programming, let's quickly review some Python fundamentals. This will ensure we are all in on the same page as we move forward. So let's start with Python syntax. Python is simple, readable, and doesn't require semicolon or brackets. Instead, it uses indentation to define block of code. Okay, so for doing that, at the beginning, let me define a Python file. For example, this is actually part1.py. This is the extension for the Python file. Here we'll actually discuss about Python syntax, variable, and function at the beginning. For example, how you can declare a Python variable. For example, to defining a Python variable, let me add a comments. So that is actually Python variable. Okay, and how you can define a Python variable. At the beginning of writing any code, you will actually define the name of the variable. That is actually, for example, name, and we'll define a assignment operator, that is actually equal sign, and then we'll define the value of the variable. So we can assign anything here. So for example, let me write my name. So this is the variable name, assignment operator, and finally this is the value of this variable. Okay, so it's very simple. You can see it doesn't require any semicolon or brackets here. Then if you want to print this, how is it possible? So for doing this, let me define the keyword, that is actually print. This is reserved keyword for printing something, and if you pass this variable name inside here, that is actually name, and then if you use an extension, that is actually code runner. I hope you will just add this extension to your VS Studio Code, and then if you run your projects, you can simply, so it's actually, if not working, what you will do, you can run Python file from here, and then let me close this again. Now run again, and then if you hit this play icon, then you can see it's actually giving you output. That is actually the name you define for the variable. Okay, So I hope you understand this, how actually variable works. The next thing we will clear how you can write a function. So for doing that, let me add a comment. So declare declare a function. Okay, so to define a function, at the beginning you will have to define a dev key. So this is the reserved keyword for defining function. Then we'll rewrite the name of the function, that is actually, for example, greet. And after then we'll take a parenthesis, that means first bracket, and inside this parenthesis you can pass your parameters here. And next, what you will have to do, you can simply define a clone and take a enter. And here we can simply define a print keyword, that is actually simply print hello. So if you call this function, it actually print hello. So let's try to call it. If you don't call the function, it actually not execute. So that's why we'll have to call it. So for defining this, great, and to call the function, you have simply just close the parenthesis. If you run this, you can see it's actually printing hello. Okay, but what about if you want to pass any parameter from here, for example name parameter, and if you want to print this dynamically, so that's why here you can simply define if, and then if you want to dynamically print the name of the person, for example if you pass name, the argument or the parameter from here, what it will do, it actually require the argument from here. We'll have to define, for example, let me define my name from here. Now if you call or if you run this, actually you can see hello Mamun. If you just define any name here, it will actually greet the person. For example, if you define Alice, then look, if you run again, it's actually greet the Alice. Okay, so this way actually function will work. Function takes a name as an output and returns a greeting. And as you know, function are reusable block of codes. It's a reusable block of codes. Later we'll learn about classes, and we will see how function can evolve into methods that belong to a specific object. The next thing, we will understand data structure. It's very important to know data structure. So next, let's talk about Python's built-in data structure that's serves as actually list, dictionaries, and tuples. These are crucial for organizing and sorting data in your program. Okay, so for doing that, what you will have to do, at the beginning we'll talk about list data type. So let me add a comment. We will simply define list data type. Okay, so how you define a list data type, actually a list is a ordered and mutable collection. Okay, so we can say you can just mutate it, and it actually doing or organizing all its element in order. Okay, so if you want to make a list for a fruits, okay, you would like, how you can do that, you can simply define if fruits fruits, then assignment operators, then we can simply make a list by using a square brackets. So inside it actually will define the element of this list. For example, we can list a fruit, that is actually apple, and then if you want to add another element to this list, how is it possible? Okay, you will have to define it by using a comma. For example, let me define banana here. Then if you need another items, you can simply define cherry. Okay, so now we will have three elements inside a list. Okay, so what if you want to print any element from this list? Okay, so for doing that, let me define print, then we can simply call fruits. Then we will have to access the element of this list by using actually indexing. So to access indexing, at the beginning you will have to define a square notation, and inside it actually you will have to say the index of the element. So index starts from 0, then 1, then 2. Okay, so if you want to print apple, you will have to define the index actually 0. So by doing this, if you run the code again, you can see it's actually printing apple. If you want to print banana, you can have to simply modify this. So now banana is the indexing of actually 1. We'll have to simply define 1. Now run again, you can see banana is now printing. Okay, so this way actually list data type works. Next we'll cover actually dictionary. So dictionary data types. Okay, so dictionary store data as key value pairs. For example, if you want to make a dictionary for a student, we can simply name that dictionary. So that is actually a student, and as you all know that a student has a specific name and others actually properties. For example, let me define a curly braces and keep remind that always you will have to define a dictionary by using a curly braces. Then inside it actually will have a properties. So property contain key and value pairs. Okay, so for doing this, if you want to define the name of the student, you will have to define the key. So this is actually key, and then you will have to assign a clone. Then you will have to define the value of this key. Okay, so for example, this is actually Alice. Okay, so this way actually you can define the properties of a dictionary is using actually key, and this is value. And if you want to define another properties, you will have to use a comma. Then for example, if you define the age of this person or the student, you can do it by this way, age and clone, then the value, that is actually 21. So our dictionary is a very simple dictionary is done. Now what if you want to print Alice, how is it possible? So for doing this, let me define print, and then you will have to call the dictionaries. Then we will do the same way as we did using actually a square notation. If you define a square brackets, then you can see it's suggesting age and name, the properties or the key of the dictionaries. So if you want to print Alice, you will have to choose the name. Then if you run, you can see Alice is printing here. So if you want to print actually is, you will have to define is here inside this square brackets and run. It's actually printing the age of the person. Okay, so this is actually dictionary data types. The next thing is that we'll have to talk about tuple. So for doing that, let me define tuple data types. Okay, tuple is immutable. That means you cannot change this collection. Okay, so we can say tuple a immutable data types. Okay, so for example, if you make a coordinates, so for doing this, let me define coordinates, and it's actually taking value inside a parenthesis. For example, this coordinates has two value, one is actually 10 and the second one is actually 20, and you will separate this by using a comma. So if you want to print 10, how is it possible? For doing that, you will have to call print, then coordinates, and again a square notation, and inside it you will have to pass the indexing. So indexing is start with 0, so we'll define 0 and run this. You can see it's actually printing 10. Okay, if you want to print 20, you will have to define indexing on here and run again. You can see it's actually printing 20. So this way actually tuple data types will work well. We all use this data structure extensively when working with class and object. The next thing we will cover about Python libraries. Lately, we will briefly look at importing and using library in Python. Library extend Python's function and make it incredibly powerful. So for example, how you can use built-in math library. For doing that, let me take another Python file, that is actually part2.py, and here actually we will just import Python libraries. So at the beginning, let me start with built-in library, that is actually Python math library. So to import any library, you will have to define import keyword. Then you will have to define the library name. For the built-in library, we'll have to define, for example, for math library, we'll have math. Okay, so by defining these, we'll actually importing math library. And how you will use this library, for example, if you want to just print the square root of a number, how is it possible? You will have to define a math library here, then you will define dot, and then you will choose any method from this library. For example, you can see there are lots of method, but for simplifying these, let me take a square root, and inside it, if you pass a number, it will actually return the square root value of this number. For example, if you define 16 and now run your code, you can see it's actually printing 4. That means it's actually giving the square root value of 16. This way actually library will work. All right, let's put everything we have reviewed into practice with a fun interactive activity. We're going to create a simple daily expense tracker using a function based approach. Later in this course, we will refactor this into an object oriented solution. So for doing that, let me create a new file. It's the first practice project of this lesson. So let me define practice project, or we can simply define project underscore 1.py. This is Python file, and at the beginning of this, let me comment the project is actually daily expenses tracker. Okay, so this is the thing we're going to make. Okay, so here how the program will work, we will store our expense in a list, and then we will have to write some function to add, view, or calculate the total expenses. So let's write the code step by step by following me. Okay, at the beginning we'll have to write a list. So let me name it, that is actually expenses. Okay, it will be a list data type, and inside this list actually we will store, what we will store, we will actually store dictionaries. Okay, dictionaries of expenses. Okay, it's right now a empty list. This is actually listed data type, and we will store element that will be in some dictionaries. Okay, next thing is that we'll have to define some functions. At the beginning we'll create a function for adding expenses, so adding expense function. Okay, so for doing this we will call dev key and define a name of this function, that is actually add expenses. Okay, and this function will receive actually two things. One is actually description, and the second thing is actually amount. After doing that, we'll have a clone and then press enter. Here we can simply look inside this list, we will have to append some element. Okay, the element will be dictionaries data type. If you look the past part, then you can see actually this is actually the way how we can create dictionaries. We will append these actually inside this list. Okay, so for doing this, as it's a list, we can append new element inside it. So that's why let me call expenses, then the append method will add element to the list, and inside this actually what you will have to do, we'll have to create these dictionaries. Okay, so to define dictionaries, what you will do, you will have to take a curly braces. Okay, then inside it actually will have properties have the key and value pair. So for the key, that is actually the first key will be description, and the value of this key will be this description. Okay, so we'll simply define description, and we can store another property by separating comma, and the second property will be amount, and the value of this amount will be this amount we're receiving as a parameter. Okay, so this is the function to add expenses. To view expenses, we'll have to create another function. So let me add a comment. That would be actually view our expenses function. Okay, so for doing that, again dev, then we will define view underscore expenses will have parenthesis then clone, and after doing that we will take a for loop. Actually, why for loop? Look, this is actually list item, and on this list actually if we do loop, then it actually every time it will give you single expenses. Okay, so for doing that we will have a for loop on actually expense, for expense in these expenses. Okay, in these expenses we'll have a clone, and after doing that we'll have to press enter. Here we'll simply define print, and we dynamically print something, so that's why if, and inside it actually we'll have curly braces, and we will simply print a description. So that's why expense right now we'll have to define, sorry, we'll have to copy this, we'll keep it here. Let me copy it inside this. We'll have to define expenses, and then square notation. Here we can simply define description. Okay, to print the description, and after doing that, for the next actually we can simply define a dollar sign to print the amount. So that's why curly braces will have expense, then to just print the amount. So this amount will have to write the name amount. Okay, this is done. Now what if you call this? Okay, so for doing that, at first let me call the add expenses. So add expenses will have to pass two value. One is for lunch, actually lunch, and the amount of the costing for the lunch is actually, for example, 12.50. and then what if we want to call view expenses function here, then if you just run your code, you can see your lunch is actually $12.5. Okay, next what if you add another expenses? Okay, for example here add expenses, and this is for coffee actually FFEE, then the amount is 3.75. okay, now if you run this, you can see it's actually coffee bill, and the above is actually lunch bill. If you want to calculate total, what you have to do, you will have to add another function. So let me make a function here, calculate total amount of the expenses. Okay, expenses. So for doing this, we will have to define a function that is actually calculate underscore total. Here we will have, doing this, simply what we will do, we will have to define total, and this total will be, we will call the sum method, and inside this actually we will have to define expense, then we will add amount. Okay, and then actually we will include for method, actually for loop here, that is expense in expenses. Okay, expenses. So I hope you can understand. Actually, we are making total. This is the variable name we are going to assign. Actually, we call sum method, and inside this sum we will just get the expenses amount. So from the actually expense list by using a for in loop. Okay, so next thing we can simply print it by doing this way. We will have to take if and quotation here, the total expenses is actually, we will add a dollar sign curly braces, and here we'll pass the variable name that is actually total. Okay, finally to calculate total we'll have to call it. So here you can simply call the calculate total by doing this. If you now run this, you can see the total expenses is actually 16.25. if you increase the value, for example here this is actually 13, then if you run again you can see the total expenses is 26.25. if you just decrease the value to 1.75 and now run it, you can see it's actually now 14.25. so our basic program is working perfectly, and this is actually a program to calculate our daily expenses. You can just add, view or calculate your expenses. So this is a procedural approach, but as we move into object oriented programming, we will see how to organize this better using class. Okay, good job. This activity give you a taste of what's to come. Next we'll dive deep into object oriented programming and create even more powerful reusable code. See you in the next lesson. Now this time we're going to clear our core concept of object oriented programming, and at the very beginning we will discuss about classes and objects. What are classes and objects? Class, actually a class is a blueprint or template for creating object. It defines attribute and methods that the object create from the class will have. And on the other hand, the object is an instance of a class. It represents a specific entity that has attribute and behaviors defined by its class. Okay, so that is actually relatively used. Class is a bigger concept, and on the other hand object is created from actually class. Okay, so if you want a real world analogy, then I can say a class is like a blueprint for a house, and it describes how the house should look like. For example, the number of room, design and its size, for example, and all its is a blueprint of a house. On the other hand, an object is the actual house built from the blueprint. That means this is the visually appealing part. Okay, so this is the concept. Now let me write a class. So at the beginning we'll create a new file that is actually, let me define part underscore one dot py, and here we will add a comment. At the beginning we are going to write a class. So define a class. So for doing this we will have to use a keyword that is actually class, and then we will have to type a name of the class. So that is actually, for example, a car, and then we will define a clone. Then we will take a enter, and simply we can type pass. This means actually no content yet. This is actually empty class. We have no content for this class, but it defines the car class. Actually this is the way we can define an empty class. Okay, so if you want to create object of that class, how you can do that? Okay, so let me add a comments here. Create objects of the car class. Okay, so how you can do it? For example, we can make a new car that is actually car 1. So to define a object, we'll have to define an assignment operator, and we'll have to call this car. Okay, so we can simply call this car class. Okay, so this is the instance of this class. Okay, so car1 is actually a object. This is a object, and you can say it the instance of the class. Okay, it's the object of the car class. Okay, then if you want to make another car, so you can just define car2, and again we'll have to call the car class here. Okay, this is also an object of the car class, and we can say this is actually instance. Car1 and car2 is the instance of this class. Okay, now if you want to print it to check what output you get, for example, let me define print, and if you want to print car1, then run your code. You can see actually we will have to run it by using Python file. Let me run it. Now you can see you can get this type of output, and these actually ensure it's actually an class of Python files. Okay, so it's ensured that you are going to define class, and you can see this is actually the object. So this car1 and car2 is object of the car class. Okay, so if you get this output, you are on the correct path. Okay, so if you understand this, now write your first class and creating an object. So we will make another part. So this is actually part 2 dot py, and here we'll create another class. And now I hope you will have proper understanding of creating class and object. Okay, so let me add a comments. So that is actually write your own class and object. Okay, so for doing that, actually at the beginning what you will have to do, the first step on is actually you will have to define a class. Define a class. Okay, so let me take a class keyword, then we will just add a name for this class, that is actually dog. Okay, then we will have a clone and then press enter. Okay, so here actually we will just write a function inside it, so that's why we will have dev keyword, and then we will name the function, that is actually bark, and this function just will have something like this, and we can simply print something from here. Print actually oof. Okay, we will have to add a single or double quotation from here, so oof. Okay, and here we can simply define a self keyword. So self keyword. Okay, so this is the parameter of the function, and if you define a function inside a class, this is actually a method. Okay, now this time what we are going to do, we are going to actually on the step 2 we will have to make a object of the dog class. So let me create an object of the dog class. Okay, so for doing this, that is actually my dog, we can just simply name it my dog, and here we'll have to actually call dog class, and then we can just create an instance of the class. Okay, so to call the method, that means if you call the function, the way is here, the step 3, and that is actually call the method, okay, of on the object. Okay, so for doing this, this is actually step 2 How you can do that? You can simply define my dog, and then if you want to call this function, you will have to do it using dot notation. So here if you define dot, you can see it's suggesting bark. So we are just going to call this method. What output you will get? It actually print this word, that is actually oof oof. Okay, so let me run this. Now you can see it's actually presenting oof oof. That means our instance is working perfectly. We have defined a class that is actually a dog class, then we define an instance that is actually my dog, and by using this class actually here, and finally we will simply call the method we defined inside a dog class. Okay, and it's giving me an output that is actually oof oof. Okay. Okay, so we already learned how to create our own class and object, and this time actually we'll cover attributes and methods. We'll define attributes and methods inside a class, and but before that let me create a new file here, that is actually part underscore 3.py, and we're going to discuss about attributes and methods. Okay, so attribute is something like it's a characteristic or properties of an object. If you have an object, then it's actually define the characteristics of the object. For example, a person have some attribute like name, age or height. On the other hand, method are function that define the behavior of an object. Okay, for example, a person can perform action like walking or talking. Okay, so let's visualize this using a class. So that is actually we'll make a class for the person, and we will visualize our concept. Okay, so this is the class, and the class name is actually here person. And then what you will have to do at the beginning, we'll learn how to define attributes. So here let me define attributes, and inside it actually we can say it's actually characteristics. Okay, characteristics of the person. Okay, for example, this person has a name, so that's why it will be name, and this is actually a attribute, and we can simply define the name is actually Johan. Okay, and then this person can have another attribute that is actually age, and for now actually we can define the age of this person is actually 30. So this way we can define attributes. Okay, the next thing is that how to get access these attributes. To get access, so let me create an object by using this class. Okay, so create an object, okay, from the class. Okay, so for doing this, for example, we can create a person that is actually person on, and for this we can simply call this person. So let me call person class. Okay, fine. Now if you want to access the name of this person, and as you can remember, it's actually called it instance. Okay, so for example, if you want to print the name of the person, we can simply define print, and then inside it actually we'll have to call person on dot, and we can get access the attributes by using dot notation. And if you define dot, you can see it's actually suggesting name and age. If you have another attribute, for example height, and that is actually uh, 33 centimeters or actually something like that, you can get suggestion of the height. You can see, so it's actually suggesting. So if you want to print the name of the person, you will have to use this dot notation. Then if you run it, you can see it's actually name. If you want to access the age of the person, you will have something like this, run it, you can see it's not printing. Okay, so next thing is that we are going to create some methods. Okay, so let me add a comment, methods. So methods actually is you can simply say it's a behavior of a person. Okay, behavior of the person. So for example, this person can grade. So that's why here we'll have to define a function, and here the function name will be grade, and by default we'll pass self. Okay, what is actually self? Okay, so self is actually the default parameter the method receive. If you define a function inside a class, then it is actually called it methods, and self refers to the current object. It's actually referred to the current object or the current instance. For example, the person one of the class, it allow access attributes that is defined above. If you want to access name, you will have self dot name, or if you want to access age, it will have self dot age. Okay, so we'll just clear it within a few seconds. Let me define something here. We would like to print something, so that's why we would like to print dynamically. We will have f, and inside it actually we will say hello, then it actually say this is, and we will just print this name of the person. So we actually just print the attribute. So if you want to just print something, what you will have to do, you will have curly braces, and you will have to define the name by using this self. Okay, so we'll have self, and if you define dot, you can see it's actually suggesting name is. Okay, or height, we will define self dot name. So this way actually you can use self. It actually refers to the attribute or methods inside a class. Okay, and then if you want to print the age, I am actually will have to define curly braces. We'll have self dot age for now, and then years old. Okay, something like this. So how you can print a method? To print a method, you will have to simply call person one dot, then you can call the method that is named grade. Okay, so person on grade, and as it's a function, we'll have to call it. Without calling it, it will give you nothing. Okay, so let me run it. You can say hello, this is John, and I am 23 years old. If you change the value, for example, it's actually 35 years old, and run your code again, you can see hello, this is Johan and I am 35 years old. So this way actually you can work with attributes and methods. So the next thing what we can learn, we're going to learn instance variable. We will create a constructor, then we will use instance variable by using self, and finally we can do some stuff. So that's why the next thing we'll just create a new file that is actually part underscore 4.py, and here we will actually learn how to define a constructor using self and others parameter. Okay, so what you can do, you can simply define the same class for the person. So class person. Okay, and this time actually we'll create a constructor. So for doing that, we'll have a div keyword, then we'll use a constructor, init constructor. Okay, so init by default receive a self, and here we can additionally pass name and age. Okay, and then what you can do, if you want to refer this name, you will have to do by using self. So self dot name, that means it will refer to this name. So that's why we will assign self dot name, that will be the name that the init constructor will receive. Okay, so that is actually name. Then we'll have self dot age, and we can simply define age here. Okay, so this is actually constructor, and here self dot name and self dot age, this is actually instance variable. Okay, so we can just say this is actually, let me define, this is actually instance variable. Okay, variable, and we can also comment this instance variable. Okay, fine. Now if you define another method, that is actually greet method, so def greet. Okay, and if you define, by default it will receive self, okay, to refer, and here we can simply print something. So that's why here we'll have if, and we'll have to say hello. Then this is, we would like to just reference the name, so that's why we'll have curly braces, and here we'll have to define self dot name, and I am curly braces self dot age, and this time actually years old. Okay, so now the differences is that we define a constructor here, so we can say it's actually constructor will have, okay, so we are defining a constructor, and inside this constructor will have instance variable. Okay, so now we will turn this class to into objects. So how you can do this? Actually, to define objects here, let me define create objects, okay, by using the class. So for example, person1, and this time actually we'll call the class person, and it's actually will be person on, and this will receive two things. Actually it will receive name and age, as we define a constructor by using init. Okay, this will actually receive two things. The first thing, we'll have to pass the name of the person, that is actually Alice, and then we'll define a comma, and then we'll have to define a value for the age, that will be something like this, 25. Okay, so if you want to grade this person on, how you can do? You can simply define person1 dot grade, then what output you will get? It will actually give output, hello, this is actually Alice and I am actually 25 years old. Let me run this code. You can see, hello, this is Alice and I am 25 years old. So this way actually we can just use constructor and instance variable. And for now actually here we use init method, and init method is actually Python's constructor method. We will clear it in the next session. Okay, so now we'll cover init method, what actually init method is. So the init method is Python's constructor method, and it's run automatically when an object is created. It's used to initialize the attribute of the object. Okay, so I hope you understand what actually init method is. Okay, always use init to set up the initial state of an object, and use save to reference instance variable. So for clearing this, let me add a new file, that is actually part underscore 5 dot py, and here we'll clear our concept of init method. So exploring the underscore init method. Okay, so for doing this, at first we'll create a new class for actually a laptop. So that's why we'll have class keyword, then we'll name the class, that is actually laptop class, and inside it actually we will have to use init method. So this is actually initial state so of the object, def underscore init underscore, and this will receive by default self to reference the attributes variable or instance variable. Then we will have to define others parameter. For example, the laptop can have a brand, so that is actually brand, and it will have a price. Okay, something like this. Okay, then we'll have a clone. Here we'll have to reference this brand and price by using self. So that's why self dot brand, and that would be the brand we receive from here, that is actually brand. And then save dot price, that will be the price we'll receive from this init method. Okay, so this brand and this price actually instance variable. I hope you already understand that, and it's actually the constructor. Okay, so it's actually the constructor. Fine. Next thing is that we would like to display details of the product. So for doing this, we'll have to create another function that is actually the method. If you define any function inside a class, that called it actually method. So here display details, and it's actually receive self. Then we will have a clone, press enter. Would like to print the details of the product, so that's why we'll have print if single or double quotation. We'll have laptop brand, and we'll print the name of the brand. So that's why we will have to access the name of the brand by using self dot brand. And then the price, to access the price, we will have curly braces, will have self dot price. Okay, we have already created a class. Now the next thing we'll have to do is the step 2, that would be we'll have to create an object. Okay, so for example, that would be my laptop. Okay, and this is the object. And then what you will have to do, you will have to reference this. So let me call laptop at the beginning, and this will receive two things, so brand and price. Okay, so for example, this is actually Dell laptop, and the price is actually $800. Okay, so to get the details of this laptop, what you will have to do, you will have to call my laptop dot display details function. We'll just call this method. And now if we run our code, you can see the brand is actually Dell and the price is actually 800. You can just use $sign to represent it better way. Okay, so you can see now it's actually $800. I hope you understand how it's going to work. We already discussed the init method and we use self. I hope you are now clear about this concept. The next thing, we'll just create a hand-on exercise. That will be, we'll create a book class, and then we will apply our knowledge that we gained from the above. We'll just make attributes, create methods, and display the price and book details. Okay, so this time actually we'll do a practical of this section, and for this let me define project, and this is actually project2 dot py. What you will have to do, you will have to create a book class. So build a book class. Okay, so for doing these steps, the first step is actually create a book class. So that's why class, and then name it book. Okay, we'll have clone. Then we'll have to initially define the initial state by using a constructor. That would be def. Then we will use init method, and this will actually receive self at the beginning. Then the book can have a title, so that is actually title, author, and it can have price. Okay, we'll have a clone, and then we'll have to reference this title, book, and price by using self. So self dot title, and that would be this title. Okay, so title, and then we'll reference author by self dot author, and that would be author, and self dot price, that would be price, and all this is actually instance variable. Okay, now to display the details we'll have to define another method, so that would be dev display details. It's similar like we did before. We'll have self inside here, and simply we'll print what would like to print. We'll have to do dynamically, so that's why if then single or double quotation will have book, then clone would like to say we would like to print the title, that's why save dot title, then we'll have a comma, we'll have author, we'll print save dot author, so save dot author, and finally we will have price. The prices will be curly braces save dot price. Okay, so and finally we'll have another method that is actually drive. We would like to get the updated price, so update price. Okay, and this is actually by default self, then another properties new price. Okay, new underscore price. Okay, so this will be, we will reference this price, so that will be self dot price, and that is actually we'll have to rename it self dot price, and that would be reference to the new price. Okay, finally we simply print something like this. We'll have the price of, here we can simply define curly braces self dot title of the book, and then has been updated to self dot price, and here we can simply define dollar sign. Okay, so I already defined some method inside it. Here we will have init constructor at the beginning. Now we'll have to create an book object. Okay, so for example let me create a new book, so that is actually book 1, and then we'll have to call the book class. Okay, and this will actually receive the three thing. Okay, it's actually receive the title, author, and price. So the book name, for example book 1, and then we'll have to define comma, we'll define a writer, so maybe let me write my name as a writer, and let me define my book price is 15.99. okay, so display the book details. What you will have to do, we will have to call book 1 dot, and then we will call the method display details. Okay, so now if I run this, you can see book 1, the author name is Mamun, and the price is something like this. Okay, what about the updated price? If you want to call this method, what you will have to do, you will have to define book 1 dot update price, and this updated price will receive a new price. So for example I would like to define the new price is now 12.99. okay, so this is my updated price. Now if I run this, you can see the price of the book 1 has updated to actually $12.99. okay, so this way actually you can have better understanding how you can just create class, how you can just create object by using the class. Then we will have already run attribute methods, the init method, actually the initial of initializing instance variable, use always self to access attribute and method inside a class, and practice the key building hands-on projects like a book reinforce this concept. Okay, now we're going to talk about encapsulation and the principle of it, and there are some different attributes, public, protected, and private attributes. We'll cover the concept in this lesson actually. Okay, so at the beginning, let me create a new file. It's a part one for the encapsulation topic, and that's why we're just renaming it part1.py. And what is actually encapsulation? Encapsulation means keeping your data safe and exposing only necessary part of it through controlled access. That means you will keep your all secret data in a safe house, then when need you can give access. Okay, so that is the concept of encapsulation, and this is the principle actually encapsulation follow. Here we will have three types of attributes. One is public attributes, second one is protected attributes, and third one is actually private attributes. We'll have to clear these concepts one by one. Okay, so we can understand that encapsulation has three type of attributes. At the beginning we will cover public attributes. Okay, public attribute. Okay, so what is actually public attributes? For example, you have a person class, so we will make person class here, and this class has an attribute that is actually name of the person, so name, and we will define Johan here. Okay, if you can do this actually, this is actually we will have a assignment operator here. Here you can see this is actually public attribute. You can access it from anywhere, any code you can read or modify them. For example, if you want to access this, how is it possible? For example, at the beginning you will have to create a object from it. For example, person 1, then we will call person class here. So this person 1 is instance, as you already know. Now if you want to access the name, how is it possible? For example, if you want to print, you can simply call person on dot name, and this will actually print Johan. Okay, so let me run this code. So here I will have to choose Python debugger from here. Then you can see the output is actually Johan. If you run again, you can see Johan is now here. So it's actually public attributes, that's why you can access it from anywhere. What if you want to modify it? If you want to modify it, you will have to do this way. For example, person one dot name, and now you would like to assign it to actually my name. So this is Mamun, and now if I run this code, you will see it's actually giving me output of my name. So that is actually Mamun for now. So this way you can just get access public attributes, and if need you can modify it easily. Okay, so here the main thing is that using public attributes when data doesn't require restriction. If it require restriction, you don't have to use it. You should use either protected attributes or private attributes. Okay, so the next thing we're going to cover is actually, second thing is actually protected attributes. Okay, so what is actually protected attributes? Protected attributes start with actually a single underscore. Okay, so using a single underscore you can just start making protected attributes. Okay, while they can still be accessed, it's convention to signal that they shouldn't be directly accessed. Okay, for example, here for this person class, again we can just define a protected attributes that is actually, for example, age. Okay, we can have a age here that is actually 30-year-old, and you want to make it protected. So how is it possible? You have to use underscore at the beginning of this attribute. If you do this, so now this is actually protected attributes. Okay, and the first one was actually public attributes. Okay, so this way you can define protected attributes. So how you can get access? To get access here, you will have to do simply person1 dot underscore s. And if you want to print this, simply let me define print. We can do it this way. So if you now run it, you can see 30 is printing. That means underscore s is protected and serve as a warning to developers to access it indirectly. Okay, I hope you understand this concept. Next thing we are going to cover is actually the third attributes, that is actually private attribute. Private attribute mark it's using underscore underscore. That means if you want to make any attributes private, you will have to make uh, you will have to add underscore underscore at the beginning of the attribute, and that can only accessed inside the class. If you want to try to access it outside of the class, it will not be available. For example, let me create a bank account class. So class bank account, and here we will define a private attribute. So that's why underscore underscore, and that is actually our private attribute is balance. And for now we'll define our balance is $1000. Okay, so here this is actually private attributes. Okay, then we can define a method here that would be something like we would like to just get our balance. So that's why get balance, and here by default it receives self. Then we'll have a clone, and here actually we can simply return self dot, and if you access this private attributes, you will have to get by this way underscore underscore balance. So if you call this method, it will actually return the balance from here. It will only work inside the class. If you try to access it from the outside of this class, it will not be accessible. Okay, so I hope you understand. So let me create a instance for the class. So that is actually my underscore account, and we will call the class bank account from here. So if you want to get the balance, so print my account dot get balance method. Okay, so this will give you output of this. Okay, so let me run this. You can see you are getting the output 1000, and that is actually by using private attributes. So here the overview is that if you want to define public attributes, it will be accessible from anywhere by using dot notation or something like that, and you don't require any underscore or double underscore to defining public attributes. And for the protected attributes, it's actually protected, and it's required a underscore before the attribute name. Okay, so next thing is that for the private attributes, you will have to define double underscore at the beginning of the attribute name, and this will only access inside the class. You cannot access it outside from the outside of the class. Okay, I hope you understand this. In the previous lesson, we have talked about encapsulation and three attributes: public attributes, protected, and private attributes. This time we will have to talk about property decorators for setters and getters. Okay, so for doing that, let me take a new file that is actually part2.py for this section, and here we will have to learn how to use property decorator. Okay, so we'll learn how to use property decorator, and the property decorator provides a Pythonic way to manage access to private attributes without requiring explicit method call. So let me explain this. For example, we will have a class for account. So we will have an account. So that's why we just define a class, and in this class at the beginning we will have to initialize it by using init method. So that's why we will have dev, then underscore underscore init underscore underscore. Here we will have by default self, then we will receive an attribute that is actually we will have balance. balance. Then what the next thing, we can simply reference this balance by self dot balance, self dot balance. Okay, balance, and this will actually the balance we will receive from here. Okay, so right now this is actually public attributes, but how to make it private attributes? So to make it private attributes, you will have to define underscore underscore. Okay, so my target to t3 actually property decorator, and this will actually give access to the private attributes. That means give access to these private attributes without requiring explicitly method calls. That means without calling the explicitly calling the methods, it will give you access. For example, for doing that, here we will have to define at the red sign, then we will call property. After then we'll have to define a function that is actually a method, that is balance, and this will have self. Next, what you will have to do from here, we'll simply return this. That means return this. Okay, self dot underscore underscore balance. So this is actually the main property decorator, and this give you directly access to the private attribute. I hope you understand. Now the next thing is that we'll have to make setter, and then we'll have to make getter. Okay, so for doing that, for making a setter, we will have to define at the rate. We will call these actually, so that is actually balance, and then we will have to define dot setter method here. Next thing is that we will have to define a method that is actually balance, and this time it will receive two things, self and amount. Okay, and then we will just simply check if amount is greater than or equal 0, then we can simply define self dot underscore underscore balance equal the amount we'll receive from here. Okay, the amount we receive from here. Otherwise we will have to define else, and from here we will simply print invalid valid amount. Okay, so what actually it will do, so this property method or this property actually decorator makes the balance, this balance actually make this balance function actually act as an attribute, for example for account, and then we will have a setter to ensure the validity before modifying these balance. Okay, before modifying these balance. Okay, for doing that, let me just run this. We'll have to create an account. So this is my account, for example my underscore account, and here we'll call actually the class account, and it will actually receive a balance. You can see it will actually receive a balance. For example, we'll pass on 100, and now if you print my account dot balance, then what output you will get? You will get actually the output hundreds. So it's actually using getter. Okay, it's actually good. We define setter here, and we will get uses getter by the amount. For example, let me run it. If you see, you can see it's $100. If I clear it and run again, you can see it's 100. Okay, so by following these, we're just call the setter to make the balance here. Next thing is that if you want to modify the balance, how you can do this? For example, my account dot balance, then you can simply modify it $500, and now if you print my account dot balance, you will get the output, that is actually 500. So these were actually property decorator works. I hope you understand this. Next thing, we're going to just do a project to build a car class, and then we will also use this property decorator and this setter and getter method to access the specific property attributes. Okay, so now we will build a car class and we will learn how to use property decorators, the setters and getters. Okay, so for doing that, let me create a new project. So that would be project underscore one for this lesson. Actually, that would be py. And here what we will do, so we will have to build a car class. So that's why we can simply define class, and that would be car. And here at the beginning we will have init method, so that's why drive and underscore underscore init. Okay, and this will initially receive speed. By default we can define a default value that is actually 0. Then we can ensure fuel level, so that is actually fuel underscore level, and that would be 100%. Okay, and here we can just reference this fuel level and speed by this way, self dot, and we will make private attribute, so that's a underscore underscore speed. Okay, and we'll just pass this speed here. Okay, and next thing is that we'll have save dot underscore underscore fuel level, fuel underscore level, and that would be actually fuel level. So this is the initial methods that we define at the beginning, and here we will have two private attributes. Okay, now we'll have to use property decorator, so that's why at the rate property. Okay, next we'll have to define a function or method here. So this is actually the attribute, it will convert by default an attribute. We will have speed, and it's actually have self, we'll have colon, and here we can simply return self, and we'll simply return the speed, so private attributes from here. Okay, the next thing we'll have to make a setter. So to doing that, actually here we will call this method speed dot setter method, and from here we will have another method, and that would be speed, and this will receive two things by default, self and actually value, and this value. Okay, we will just simply check here if we'll have to check here if 0 is greater than or equal value, and obviously greater than or equal 200, we can simply define self dot underscore underscore speed equal value. Okay, otherwise we will have else, and that would actually print what we are going to print, speed must be between 0 to 200. Okay, so and then if you want to define another property decorator, how we can do that? So for example, we will have another property director, so that's why we will define property, then we will have the same way dev, and for this fuel level, actually fuel underscore level, we will have self here, and then what we will have to return self dot underscore underscore fuel level from here. And now we'll have to define the setter, so that's why at the rate fuel level dot setter, and this will define dev, and that is actually fuel level, fuel underscore level, and it will by default receive self and value again. So then we can check if 0 is greater than or equal value, and then greater than or equal 100, the fuel level limit is 100. Here we can just define self dot underscore underscore fuel level and equal, that will be equal to value, otherwise it will be else, and we will make sure the fuel level must be in between 0 to 100. Okay, so now this time actually we will have to create a instance. For example, we are going to make a car. So this is actually car 1, and that's why we'll call our car class, and then we will ensure the car speed. For example, car 1 dot speed, and that would be 120. Okay, and for the fuel level actually we can just can make sure that car 1 fuel level would be now 50. Okay, so if you want to print actually speed, for example car 1 dot speed, now let me see how output come. Okay, let me run it. You can see it's giving you the output because the the value of the speed is in between 200 and the level is in between 0 to 100. If you make it 0 for now and run again, then you will see it's actually giving it 200 because the fuel level is 0. But what if you just increase the value to 200, the fuel level, and run it again, you can see the fuel level must be in between 0 to 100. That means you are getting an error here. Okay, so I hope you understand this. If you want to check the speed, you are getting by this way. If you want to print the fuel level, so print car 1 dot fuel level, then run again, you can see it's you are getting this type of output from here. Okay, I hope you understand all of this stuff. So right now let me make it 50 for now and finally run it. You can see the speed is 120 and the fuel level is 50 for now. Okay, so I hope you are clear right now how to use actually property, decorator, then setter, and this is actually the getter. Okay, this is actually the getter. Now this time we are going to talk about inheritance. So inheritance is if, for example, you have a parent class, and if you want to get attributes and methods from your parent class to a child class, then it will actually work this way. That means inheritance allow you one class to inherit attributes and methods from another class, and this prompts code reuses. Okay, so let's do this for now. For example, we'll have a new file that is actually for this lesson, and that is part1.py, and we're going to learn inheritance. Okay, understanding inheritance. Okay, so let's make a parent class. So here parent class, and for example we are going to make a class for animal. Okay, animal, and this actually will have a method that is actually dave, and animal is spec something like it will receive self, and then simply print I can make a sound. It's a general sound, all animals can speak. Okay, so then what if you want to just create a child class, how is it possible? For example, here child class. Okay, so for making this child class, for example, let me define a class that is actually for dog, and it's actually inherit this parent class. So that's why we will pass animal inside it. Then we will have another function that is actually a method, and it's actually has same method, that is speak, and this time it's actually self, and then it's print. Oof. Okay, so the dog is making sound oof oof. Okay, so this way we can just inherit dog class from the parent class, that is actually animal. Next, if you need another inheritance, and that would be a another child class. For example, we will have another class that is actually for cat, and it will inherit its behavior from actually animal class. So that's why we'll pass animal inside it. Then so the same thing, we will have a dev speak, and it will actually define print meow meow. Okay, so now we have create our parent class, and these are the child class. Next thing is that we will create object. Okay, so create some objects. Okay, create objects by doing this. For example, for dog, actually we will call the dog class. Okay, so let me call dog class, and then now if we define the output for the dog class, so that's why we will call dog dot speak method. Then what output you will get, it will actually give you oof oof. Okay, so let me run this code. So we'll have to choose actually Python file, and then you can see you are getting oof oof. That means the dog is making a sound that is actually oof oof from here. Okay, so though it's actually inherit this speak method from the above method, but it's actually modified it oof oof. And for the cat class, for example, here I'm just making my cat. Okay, and we can just say it's actually Tom, and now we'll call cat, and this we will called the class of the. And now if we call my cat dot speak, so we will call the method speak, and now if we run it, then you will see meow meow. So this is the sound for the cat. Okay, the dog and the cat class override the speak method that is defined on the animal class. So we actually override this method from here and obviously from here. In the previous video, actually we understand the inheritance, and here we actually learn how to inherit method from parent to child, and this is very generous way. But for now, actually we will do this same. Actually we will override methods using super. Okay, so we will have to use the super method to inherit parents method to child using a super call. Okay, so for doing that, let me create a new file here, that is actually part underscore 2 dot py, and here let me add a comment: override methods using super. Okay, call. So for doing that, for example, we will have a person class, so that is actually class, and we'll make person, and then we will have a method that is actually dev, and that will be introduce. Okay, the function name is actually introduce. Okay, and here we'll pass self, and this is actually will print something like this: hi, I am a person. Okay, something like this. Fine, so this is the method for this person class. And next, actually we will create a child class from here, so that would be something like class. And to make child class, what you will have to do, you will have to define a class name here, then we will have to pass its parent, so that would be person from here. Now we will just override these methods here using super. Okay, so that would be dev, then introduce, introduce, and here actually we will receive self, and in this section actually we will call the parent method. So that is actually introduce method inside here, so that would be super, and we will call it, and then we'll define a dot, and then you can see it's suggesting this method. Okay, it's suggesting this method. So let me show again, it's suggesting this method. So as it's a method, we'll have to call it. So here we'll call the parent method in this line. Actually you can say we just calls parent method. Okay, parent method here. Next thing, we simply print something like this: print I am also a student. Okay, fine. Next thing, we will have to create an object that is actually a student, and we'll call a student class from here. And now if you want to get output for this method, what you will get. Okay, so we'll call a student and then introduce method. So what output you will get? You will actually get two output. One is actually for this. Okay, it will actually say hi, I am a person, and you will also get the output for this print. Okay, so let me run this. You can see hi, I am a person, and I'm also a student. So why you are getting two output? Because firstly we call parents method using super call here, and then we will have another actually print. So that's why actually we're getting two calls here. Okay, next thing, actually in the next video we will just create a we will just make a project where we will have a shape class, and we will calculate, actually we will build circle, then we will build rectangular, calculate the area and others step. Okay, as we discussed, we'll make a project. For example, we'll have a shape class, then we will have some child class, circle and rectangular. We'll just calculate area and perimeters and other system. Okay, for doing that, let me make a project here, that is actually project underscore one for this lesson. That would be a Python file, and here at the beginning we will make a class for actually shape. It's a very general shape, and this is actually have an area. So the method will be dev area, and it will receive self, and finally here we'll actually simply pass it. That means it's actually empty method. It doesn't it don't receive anything here. Okay, we'll just define it later. And next we will also define another method that is actually parameter. Okay, dev perimeter. Okay, that will be obviously self. And next thing is that we'll also make it pass. That means it's actually empty method, it's just doing nothing here. The next thing what we are going to do, we will have to make a child class. For example, we'll have a child class that is actually circle. So this will extend from their parent, that is actually shape, and then here actually we will define a init method. So that's why dev underscore underscore init underscore underscore, and this will receive two things. One is actually self and another is actually radius. Okay, dius. Okay, finally what you will have to do, we'll have to reference this radius by self dot radius equal radius. And next thing is that we'll have another method, so that is actually dev area. Okay, and we'll extend actually, so we'll extend the area method by following this way. We'll simply return a calculation. We will have 3.14, that is the value of pi, and we'll multiply it using this self actually radius. So we'll have self dot radius, and we will just use exponential operator, that is actually to the power 2. Okay, so this is the calculation of the circle area, And next thing, we will just calculate the parameter of the circle. So the formula is actually, we'll have something like this. Let me define another type, that is actually perimeter, and it will be self inside here. Actually, what you will do here, will return 2 into 3.14 into self dot radius. Will reference the attribute that is actually public attributes defined it here. Okay, so this way actually we will just make a child class from actually shape, and as same actually we will have to create another child class that is actually rectangular using the shape. And here again we will have div underscore in it underscore. Here actually we will have to pass self, then we will have a length, length, then we will have a width. Okay, something like this. Next thing, we will actually reference this. That's why self dot length equal length and self dot width equal width. Okay, finally we will have a area calculation, that would be area, and it will receive self. Next thing, what we will do, we can simply return self dot length multiply with actually self dot width. So this is the calculation for the area of actually a rectangular, and then we will have div, we will calculate perimeter, so meter, and here actually it will receive self, then we will simply return to into, we will have to take a parenthesis, we'll just add self dot length plus self dot width. Okay, this is the calculation for the parameter of a rectangular. Finally we will have to test the shape, so that's why here let me comment test the shapes. Okay, and for doing this, let me create a circle, and for this actually we'll have to call this circle class, and it will actually receive a radius. Okay, so that's why let me call circle class, and inside it we'll have to define a radius. Okay, we will have to pass a radius inside here. Okay, now if you just print here circle dot area method, then what output you will get, the output will be 78.5, something like that. So let me test it. If I run this, you can see 78.5. okay, this is the calculation of the area of a circle. And next thing, if we define a rectangular, so rectangular, and that would be, we'll have to call the rectangular class, and it will have to receive actually length and width. So we'll have to pass two values from here, that is actually 4,7. and what if we just get the parameter of the rectangular let me correct it, tangl rectangle. Okay, so let me correct it. For doing that actually we will simply call print, here we'll call rectangle, and for now actually we're going to calculate parameter. Okay, so we'll have to call it as it's a method. Okay, so if you now run it, it actually give you output something like this, 2022. Okay, let me run it, it's actually 22. So this is the output, how you calculate a area and parameter from a parent class to a child class using actually this way. This is actually the example of an inheritance project. I hope you understand what we're going to make. Next thing, we will just talk about polymorphism. Okay, it's another important pillar of learning object oriented programming. Now we're going to talk about actually polymorphism. Okay, so for this we'll have a folder. Let me open it on VS Code, and at the beginning let me create a part on underscore actually Python file. Here we will just talk about polymorphism in action. Polymorphism allows method in different classes to be called it through the same interface. So and actually method overriding demonstrate polymorphism in action. Okay, so if you want a real world analogy here, if you use move method in different class, for example, you will have a vehicle class, and from there you can create some child class, car, bike, or truck behaves differently depending on the class. Okay, so let's make this. And at the beginning, let me comment, it's actually polymorphism in action. Okay, so for example, as we're going to give you the real world analogy, that is actually we will have a vehicle class. Okay, so for example, let me define a class that is actually parent class for vehicle. So vehicle, v is a call, and that would be actually, so it's actually class, and then here we will have to define a empty method that is actually move, and inside this move actually we'll simply pass self. Okay, and then we can simply define pass, it's actually empty method. Okay, so these move methods actually behaves differently depending on the class. For example, right now it's actually parent class and we use a move method. Next thing is that, for example, we will create a car class, it's actually child class. So class here we will have a car class, and it's actually extended from actually vehicle. Okay, fine. Then what you will have to do, we will also make a move method here also, that is actually dev will have move, and here we'll have self. Okay, fine. Then here actually we will print something like this, we will have car drives on roads. Okay, something like this. And now this is actually a child class of the vehicle, and next we will have the similar for bike and actually truck. Okay, for example, we'll have class, and that is actually bike, we'll have vehicle, and then actually we'll have same method inside it here. So that's why let me copy it. So for now actually, okay, so here we will have actually bike rides, actually it will be rides on road, and finally we will have another subclass that is actually class truck, and this will extend to the vehicle class, and here actually we will have Dave move drives on actually roads. Okay, here we can just do a little bit modifies fuels is a fuels goods. Okay, that means it's actually transport or transfer goods on road. Okay, so we'll have a parent class at the above, then we'll have three child class that is actually extended version of vehicle. Okay, and we just modify our move class here every inside this actual child class. Now this time actually we will test polymorphism. So here we'll have test polymorphism in action. So how you can do that, for example, you will have to make a collection of all the child class that are defined here. So for doing this actually, what you will have to do, we'll have to call it in the same interface. So for doing that, for example, we'll have general vehicles. So vehicles, VEHICLES vehicles, and here we'll call all the child class from here. So that's why we'll take a square bracket. For example, let me call the car class at the beginning, then we will define a comma, we'll call bike class, then again a comma, then we will have truck. Okay, so we are arranging every class inside vehicles, and this is actually the object. Okay, now if we just loop inside vehicles, it will just print the method that is defined here. Okay, so for doing that, for example, we will have a for loop, and we will just do, for example, vehicles, ACCLE, in actually these vehicles. Okay, then we will simply call the method vehicle dot move method. We will call the method here. Now if you run your code, you will get three output actually. One is for car, one is for bike, and one is for actually truck. Okay, so let me run it. So again, I mistake. I will have to choose run Python file. You can see I have this three thing. So car drives on road, bike rides on road, truck just transfer goods on road. Okay, so all of these three output are getting from a single actually object, that is actually the example of polymorphism. Okay, I hope you understand this. This is a very simplified example of it. In next actually we will talk about abstraction, and we will use abstract class and methods in the next video. Okay, so after the polymorphism, what we are going to discuss about? We are going to discuss about abstraction, and it's a key concept in object-oriented programming that actually focuses on hiding implementation details and exposing only essential part. It helps developers to design system actually that are easier to maintain, extend, and understand. Okay, so in Python, abstraction is often achieved using abstract class and method, and right now we are going to create a abstract class and method using abc module in Python. So let's do it. At the beginning we will have to create a Python file, and as usual we will just follow the same pattern that we did previously. We will have part underscore one dot python file, and we're going to use abc module to explain abstraction. Okay, abstraction. Okay, so an abc module in Python allow you to create abstract class and methods. And abstract class cannot be initiated directly, and they can certain abstract methods and actually and create methods. Okay, so to do achieve the goal, at first we will have to import abc class and abstract method decorator from actually abc module. Okay, so for doing that, let me write from abc. We will just import abc from actually import abc module, and we will define a comma, and we'll have to also import actually abstract method. Okay, we're going to actually import abc from actually abc and abstract method. Then we will have to define a class inheriting for abc. So that's why we are going to create a class that would be animal class, and animal class, and here actually we will use this abc inside it. Okay, so inheriting from abc, actually this class is inheriting from abc. Okay, then we will have to create abstract method. For doing that, at the rate abstract method, then we will have to define a method that would be make underscore sound, and here it will be self by default, and then we will keep it empty. That's why we will simply type path. Okay, that means this module is actually empty. Then we will have another method that is actually def, and here we will define the method name is actually sleep. It will receive self. After doing that, what we are going to do, we actually create method with implementation. So for doing that, let me print, and here we will say that will be actually sleeping. Okay, something like that. And next, actually trying to inherit an abstract class will raise an error if you actually call animal. For example, if I define animal and call actually animal class, okay, then if we run this code, so let me run Python file, you will see it's actually give you a type error that is actually instantiate abstract class animal without implementing for abstract method make sound. Okay, so you are getting this error. So to solve this, actually what you will have to do, you will have to actually implement a child class. So that is actually, for example, we will have a class, then this is actually dog class, and here actually we will just call our animal class from here, animal class, and this time actually we will have to define dave and make sound, and here actually we will simply define print, and that would be oof oof. Okay, something like this. So dog actually making this sound using this method. Okay, so now create an instance of the subclass. We will create a instance of this subclass. So how is it possible? Simply we will have to define dog or my dog. My dog, here we will call dog subclass, and this time if you call make sound, for example, my dog dot make sound, and call this method, and if you run this you can see oof oof. If I delete it and run it again, you can simply see oof oof. That means it's actually giving you oof oof output. But what if you call this actually method by using the instance, what you will get output? For example, I just simply define my dog dot sleep method from here, and this sleep method is actually defined in actually animal class, and it's actually using actually abstract method. Okay, so if you now run this, it's actually giving you output sleeping. So let me run it. The dog is now sleeping. Okay, so here actually, abstract class are helpful for designing systems that require a clear contract or blueprint for other classes. Okay, in the next video, we'll clear this concept by using a payment processor system. Okay, so I hope after doing that projects, you will be more clear about this concept. So in the previous video, actually we will have created a abstract method and abstract class by using this, and next actually in this lesson what we will do, we are going to make a payment processor system using actually the same concept, abstraction. Okay, so design a payment processor abstract class that includes the payment method and subclass with implement this method for a specific payment method such as credit card payment and PayPal payment. Okay, so let's do a project that is actually project underscore one for this lesson, or project dash one dot py. Okay, so this is the project, and this project is actually for payment processor system. Okay, project. Okay, we are just going to define it. So we will implement it step by step. At the beginning, what you will have to do, we'll have to just define an abstract class. So let me define, this is actually a step one, and here we are going to define the abstract class. Okay, so how is it possible? At the beginning we will have to import abc. Actually we will have to import abc and abstract method from abc. So let me from abc, and we will import actually abc comma and abstract method. Okay, this is the first step. Then what you will have to do, we'll have to create a class. So class will be payment processor, so that's why payment processor, and it will be used abc. Okay, So then we will have simply create a abstract method. So that's why at the rate abstract method, then we will have to define a function that is actually method. So dev actually process underscore payment, okay, payment, and it will receive two things actually by default self and then actually an amount. So something like this, we'll have a clone. Then we here actually simply process the payment for a specific amount, and right now we will keep it actually pass. That means it's actually empty right now. Then we will have to define the step 2, and the step 2 will be we'll have to create subclasses. Okay, so create subclasses, okay, for actually classes for actually payment processor. Okay, for doing that, define concrete subclasses that implement actually payment process payment method. Okay, so for doing that, let me define a class that will be credit card payment, credit card payment. Okay, and it actually receive this payment processor class, so it's actually subclass of payment processor. Okay, for doing that, we will have to define dev, and that is actually process payment. We will call process payment, and it will be same self and amount. And here actually we are going to print something like this. We will have dynamically print, so that's why if will call processing credit card payment of actually here we would like to print the amount, so that's why inside this curly braces we will define amount, and we can simply make it using two floating point. Okay, so something like this, 2f. So after doing that, what the next actually we'll have another payment actually that is actually for PayPal payment. So that's why we'll have a class that is actually PayPal payment. Okay, we are going to receive PayPal payment. That would be the same uh, process actually payment processor. Okay, we can simply define the same way. So let me copy this and we can simply pass it here. That will be right now it will be processing PayPal payment okay, we can keep it capital later, and I think everything is fine right now. Okay, so next thing is that the step 3, that would be actually step 3, that would be uses the class. So that's why here use the classes. Okay, for doing that, let me define a function here that is actually drive, and this function name is main. And if we call this main function, it actually we will make a list. So that's why payment underscore method, and that will be a list. So inside this list actually we will simply call the two subclass we created, that is actually credit card payment, we'll call it, and then we will define a comma PayPal payment. Okay, finally we will do a for loop. For doing that, here actually we'll have a for method in payment underscore method, and we will simply call actually payment dot method dot process payment, and we'll pass a amount, for example 100.50. and now what we are going to do here actually, after the end we'll check if dash name dash and we'll define a equal operator here, and we'll simply define underscore underscore main underscore underscore, and finally we can call the main function. Okay, so we call the main function. Now if you run your code, of what output you will get. So let me run this Python file. You can see the processing credit card payment, that is actually the amount, and you can also see the processing PayPal payment, actually $100.50. Okay, so we're getting the perfect output. This is the output. So you can extend these projects if you want, actually, but for now I think it's okay. If we need, actually we will do it later. After discussing the payment processor system, actually next actually we're going to move to advanced concept of object oriented programming, and for this actually we will have a folder. Let me open it on VS Code. So at the beginning of this, actually we're going to talk about magic method. Magic method is called it Dunder method because they are surrounded with double underscore. Okay, and it's actually allow you to customize and extend the behavior of Python class. Okay, so there are several type of magic methods, and we will discuss it is step by step. Okay, so don't be worried about it. For example, let me create a new file. So I would like to show you practically. That would be part underscore one.py, and we're going to talk about magic method. Okay, so magic methods. Okay, and at the beginning we will have actually the first one. We will have actually four magic methods. The first one is actually underscore underscore str underscore underscore method. Okay, so this method actually represent a string, so it presents a string. Then we will have another method that is actually dash dash repr, that is represent actually provided a, also it's actually unambiguous string representation. It's also string representation, so string and of an object for developer. Okay, it's actually represent a string of an object for a developers. Okay, next we will have actually length, and represent actually the behavior of length of your object. So it's actually represents the behavior of length, so length for your object. Okay, for your objects. Okay, and finally we will have the next one, that is actually step 4 underscore underscore add. Okay, underscore underscore, and this is actually represent plus operator, so plus operator for objects. Okay, so we will just give you practical implementation of it, so don't be worried about it. So let's implement this step by step. At the beginning actually we are going to talk about the first two one. Okay, so we are going to talk about the first one, so let me add a comment. So we will going to talk with str and actually underscore underscore repr. Okay, methods here. Okay, so for doing this, as you know, str actually for human readable representation of an object, and repr is an ambiguous representation meant for debugging. Okay, so let's implement this. For example, we will have a class for person. Okay, we will have a person class, and this is actually at the beginning we will have a default init method, so that is actually init method. And this init method actually receive two things. One is actually the name of a person and age of a person. Okay, and here actually we will do reference. It's actually public attributes, so that's why self dot name, and we will pass actually the name that it will receive, and we will have another self dot age. Okay, so next thing is that we're going to use str method. Okay, so underscore underscore str method. So for doing this, dev underscore underscore str method, and here actually what it will return from here will simply return something like this, will return f, and here we would like to just print the person name, so that's why we'll reference it save dot name, then we'll add a comma and say it will actually self dot is, and finally years old. Okay, and next we'll use actually repr method. So for this actually let me define dev underscore underscore repr method, and here actually we will simply return f, and that would be dynamically we will simply define say actually person, and here we can simply say name equal, we will have a single quotation and say self dot name, and then we will close the single quotation, then we will define a comma and say is, that will be, will simply say self dot is. Okay, something like this. So for doing this, next thing is that demonstrate underscore underscore str and actually repr. So for doing that, so here let me add a comment, demonstrate these two method and actually rpr method. So for doing that, for example, let me create a actually object that is for person, and this will receive two things actually, a name that is actually Alice and a age that is actually 30. Okay, so now if you print this person, or that means actually print p, what you will receive, it's actually called str method, and it will actually give these output. Okay, it will actually give these output. Okay, so let me run it. So if you run, you can see Alice is now actually 30-year old. It's just printing this line because by default it's actually called str method. Okay, next thing, what if we print actually repr, and inside here if we pass our class that is actually p, what output we will get, actually it will say something, it will actually call this method and actually print person, and inside these actually will have parentheses, will just print the name and age inside these parentheses. Okay, so let me run this code, and now we can see it's actually printing person, here name is Alice and age is this way, and that is actually repr method. Okay, to call repr method you have to define it repr, and inside it you will have to pass your object. Okay, so the key point here is that str is used when object is converted to a string or printed. Okay, that means it's only used when actually object is converted to a string, and reper, that means this method is used in debugging or when the object is displayed in the console. Okay, so that's why here we're simply use repr, this is used actually for debugging purpose. Okay, next thing we're going to talk about underscore underscore length, and it's actually the purpose to use length function behaves for your object. Okay, so for doing that let me create a new file. Okay, we can just do it in this file, or we can just create a new file that's actually part underscore 2.py, and in this section actually we're going to talk about underscore underscore len underscore underscore. Okay, so for doing that we are going to define a class that is for book actually, and here actually we will have init method, so that's why dev underscore underscore init underscore underscore, and here actually it will receive self, then it will have a title, then we will have a page counts. Okay, that is actually pages, and simply we will reference this. So that's why save dot title, and the title is equal the title that is received from here, and we'll have pages. Okay, by this way. Next thing is that we're going to use the length method. Okay, so that's why dev underscore underscore length underscore underscore, it will be received by default self, and after doing that it will simply return the pages, self.pages. Okay, so how to demonstrate it? For example, to demonstrate, so demonstrates underscore underscore length underscore method. So for example, we will have to create a object that is actually book, and here we'll call the book class, and inside it actually we will say the book title, that is actually Python basics. Okay, Python basics, BASICS basics. Okay, after doing that we'll have to define the page count, that is actually $350. Sorry, 350. Okay, so now if you print, and we'll do it using length method, and here we'll pass the book, what output you will get? It will actually give the output of this. Okay, so let me run this code. You can see it's actually giving you 350. Okay, that means 350. So this is actually the page count, and this length underscore underscore actually length, what it will do, so it will actually simply allow you to define a meaningful length of a custom object. That means using this actually you can just calculate the length of your custom object. And next thing we will use add underscore underscore add actually method. So for doing this, what we'll do, let me define another part3 dot py file, and here we'll calculate the length. Okay, sorry, underscore underscore add. So let me add a comment. We'll talk about underscore underscore add method. So for doing that, let me create a class that is actually for vector. Okay, vector class, and this will have a init method, dev underscore underscore init underscore underscore, and here it will receive actually self, then it has an x-axis value and y-axis value. Okay, we will have to reference it, so that's why self dot x, that is actually x, and then we'll have self dot y, that is actually equal to y. Okay, so we're defining a init method, and next what we will do here, actually we'll have to use underscore underscore add method. So it's actually customize how to plus operator works on your object. So for doing this, let me define dev underscore underscore add underscore underscore. Here it will have self, and then the other parameter will be other. Okay, so here we will simply use instance, okay, method here. So if is instance, okay, and inside it actually we'll have to pass other and the value of this vector. Okay, so we'll simply pass the object vector, and for doing that, that means we'll pass our class here, and that will actually return we'll simply call vector, and here actually we'll call self dot x plus other dot x, then we'll define comma self dot y plus other dot y. Okay, so now from here in the next line we'll simply raise type error, and that would be can only add vector to vector. Okay, so something like this. And finally we will also use underscore underscore repr. So the method we worked with later, so previously actually, so that would be dev underscore underscore repr underscore underscore and it will receive self. Okay, next thing is that here actually we simply return. So if we will have to define dynamically here the vector, and here we'll actually define x equal, we'll have curly braces self self dot x, and then we'll define a comma, and we'll say y equal curly braces self dot y. Okay, something like this. And now demonstrating actually, so demonstrate underscore underscore add method. So for doing this, for example, we'll have v1, so object, so that is actually we'll call vector, and here we'll actually pass 1 and 2. Okay, and we'll also have actually v2, and inside it actually will pass 3 and 4, and on the actually we'll have another vector, so that is actually v3. We will just do addition, so v1 plus v2 here. So this is actually, we can just simply say this is actually here actually calls underscore underscore add method. Okay, here actually we are going to calls underscore underscore add method, and finally we just simply print the third vector, that is actually v3. So here underscore 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 add underscore underscore, this method allow you to define custom behavior of AND operator. So, and it's always actually handle type checks within the method to ensure the valid actually operator. So if you run right now, you can see you are getting the vector x is 4, and now it's actually 6. This is the calculation for actually v1 plus v2. Okay, I hope you understand this. Okay, so after discussing all of this, next thing is that we'll have to talk about class versus static versus actually instance method, and we'll clear the concept. So for doing that, here we'll create a new file, that is actually part underscore 4 dot py, and we're going to discuss about actually, so instance versus class versus actually static methods. Okay, we will learn the differences in between them. Okay, for doing that, actually instance method actually operates on a specific object instance, and on the other hand class methods operates on class itself rather than instance, and static methods don't depend on instance or class specific data. Okay, they are actually utility function. So let me clear one by one. So at the beginning we'll start with instance, so tnc instance method. Okay, so for doing that, what actually instant method, it's actually, let me add a section, it actually operates on an instance. Okay, instance of a class, so let me give you an example. For example, here we'll have a class that is actually, for example, employee, and this class has an init method, so that's a dev underscore underscore init underscore underscore, and this actually receive by default self, then two parameter actually name and salary. Okay, and this time actually we will have to reference it by using self. Here the first parameter self is actually the always the instance method. Okay, so the first parameter is always the instance method. Here what we will do, we can simply reference it by using self dot name will be the name of the employee, so name of the employee, and then self dot salary will be the salary of the employee. And now if we define another method that is actually display details of the employee, so that's why dev display underscore details Okay, it will receive self, and then what we'll do, we can simply return a dynamic string that will be name. It will represent the name of the employee and the salary of him. Okay, so now demonstrating instance method, how to do that. So for doing, let me add a comment, demonstrate the instance method. Okay, for doing that, actually let me create a employee one. So employee one, and it's actually instance of the class employee, and it will have to pass two things. One is actually employee name, for example it's actually Alice, and the salary of the employee is actually $50,000. Okay, so something like this. Now if you want to print, so print the details of the employee, so you will have to call employee one, then you will have to get access the method display details of the employee and call it. So now if you run your code, so let me run using Python, you can see the name is Alice and the salary is $50. If you define a dollar sign here, then it will give you exactly so name Alice and salary is $15. If you have another employee, for example have employee 2, employee employee 2, and now you call employee class and say it's actually Bob and the salary is actually $75,000. Okay, now let me print employee 2 details. Okay, now we can see the Bob and salary is $75,000. So this is actually instance class. Here we will simply call the display methods here actually on an instance, and this instance method can accessible or modify actually instance variable, for example save.name or save.salary by doing this, and they are called it using an instance of a class. So this is actually instance of a class. The second actually method we're going to talk about, that is actually class method. Okay, so this is actually class method. So class method actually what it operates the class itself. So using actually class method decorator, so it can actually give you accessible or modify class level data, and you can demonstrate it by using class method operator, and the first parameter cls refers the class. So for example, for doing this, let me create a class level attribute. So for doing this, for example we'll have a company name here, company underscore name, and we will simply define this is actually take shop. Okay, something like this. So and here this is actually class level attribute. As you know, it's actually class level attribute. Okay, now if you want to access or modify this class level data or class level attribute, you can use it by using class method decorator. So how is it possible? For example, let me define a class level class methods. Okay, so for doing this, actually we will have to simply define at the rate class method, and then we will define a function that is actually set company name. Okay, def set underscore company underscore name, and it simply receives cls. This cls actually reference the class, okay, that is defined here. So this is actually reference the class, and then we will have to pass a name of the company. Then simply we can simply define cls for as a reference, then we will define look the class attribute from here. So that is actually company name, and we will simply assign the value of the name here. So this way actually we can modify the company name. Okay, so after doing that, we'll have to make another function or method that is for actually how to get the company name. So for doing this, we will have to define at the rate and class method again, and finally we will have to write a method that is actually get underscore underscore company underscore name, and it will actually receive CLS for referencing the class, and finally it will return CLS dot class name. Okay, so now to demonstrating these actually how to do that, you will have to directly call the class, for example employee. So we are just directly call the employee class, and then we can set the company name here. So right now it was actually tech shop. Now we'll define uh, Tesla, Tesla for now. And here actually you can see we are just calling this actually method by using class method to customize this company name. Okay, so after setting this, how to access the class level attribute through the class method that actually defined here. Okay, for doing that, we have to simply print, we directly call employee class, and then we can just get company name and we simply call it. Okay, so now if you run this code, you will get Tesla. That means it's actually returning this. Okay, it's actually returning this company from actually company name. So by this way, actually what you can do by using class method, you can easily modify any class level attribute. For example, this class name, we just modify it here and we get the modified results by using this method. Okay, so you don't need to depend on instance specific data. You can easily modify any class level attribute by using class method. Okay, and next thing we're going to talk about actually a static method. So for doing this, so let me define another comment. So this is actually a static methods, and it's actually don't access or modify class. Okay, so the main thing is it's actually don't access or modify class or instance data. Okay, let me correct this, class or instance data. Okay, so the main thing is this. Okay, fine, then you can use this by using a decorator that is actually a static method. Okay, so for this actually let me create a new class. So for example class, and that would be math operation. Okay, so math operations. Okay, operations, this class has a static method, so that's why at the beginning we'll have to define at the rate sign, then a static method, and then let me define a function that is actually add two numbers. For example, add underscore numbers. Okay, and it will receive a and b as numbers, and it simply return a plus b. Okay, it's actually directly a function, and uses the static method. Okay, for example we can just make another static method. So a static method, and this is for actually how to just multiply two numbers. For example, multiply underscore numbers, and this will receive a and b, and finally it will actually return a into b. Okay, so we have created some function using a static method, and right now we will demonstrate this. For demonstrating this, you can simply call print, sorry, we'll have to call print, and we can directly call actually our class that is actually math operations, and to access the method of this, for example we'll access the add method at numbers method, and here we'll simply pass 10 and 20, and what output you will get. It actually give you output, for example, 10 plus 20, that is actually 30. So let me run this. You can see you are getting 30. Now if you just try to check the multiply method by using directly the class method, so multiply numbers, and if you pass actually 5 into 4, and if you run your code again, you can see the output is 20. So here the key point is, using a static method you can independently both class and instance. You can use actually independently both class and instance, and they are ideally for grouping utility function. It's actually group utility function, so have a logical association with their class. Okay, so after discussing about actually three types of methods differences, one is actually instance, class, and static methods. Next thing is that we'll talk about difference between composition and inheritance. So you will understand the difference between composition and inheritance, how to use and how to apply them effectively. Okay, so for doing that, let me create a folder. So this is actually composition versus inheritance, is TANCE. Okay, and inside it actually, let me create a new file, that is actually part1.py. so now here actually we are going to talk about the difference between inheritance, and for the part 1 actually we'll cover what is inheritance and their uses. So let me add a comment, that is actually inheritance and its uses. Okay, uses. Okay, finally. Okay, what is actually inheritance allow a class, so it's actually child class, to inherit some properties or behavior from its parent class. So that means you have a parent class, and from the class you can create subclass and access the parent's behavior or attributes, okay, by using this way. So for example, let me implement it practically. For example, we will have a class that is actually for vehicle, so VEHICLE, vehicle, and this class has a method that is actually in it method underscore, and here actually it will receive by default self, then the vehicles has a brand, so that's why brand, and it can have a speed, so that's why we'll pass these argument from here, and we'll have to reference by using self, so that's why self dot brand equal the brand it actually receive as a argument, then we'll have self dot speed, and the speed will be as the speed it receive. Okay, so this is the method, and we will define another method. For example, you can just drive the vehicle, so that's why we will have another method that is actually a function drive, and it will simply receive self. It actually returns something, that is actually it will return dynamically a string, that is actually the vehicle. So the name of the vehicle will be came from self dot brand, so brand, then we can say is driving at, actually we'll just print their speed by using self dot speed. We are just referencing the speed. By this way we will define kilometer per hr. Okay, that means hour. So this is actually the parent class. We can just say a comment, we have a parent class, and now we'll create a subclass. By using this parent class, we sometimes just access these actually attribute from the child. Okay, so for doing this, let me add a comment. We are going to create a child class, so child class. For example, we are going to make a car by using these parent vehicles. Okay, so for this we'll have class, and for car actually this is the class name, and we'll inherit the characteristics from actually vehicle. so that's why we will have to pass vehicle inside it. Then we will have the default init method here, so that is div actually underscore underscore init underscore underscore, then it will receive self. Additionally, it also received the characteristic from parent, so that is actually brand. Then it will receive speed, and additionally it will actually receive number of doors the cars has. Okay, so next thing is that we'll use super key to access some uh, attributes from the above, so that's why we will have to define a super key. Okay, let me call super, then we will call the method to access the attributes or methods from actually its parent. Okay, then we'll see, we'll call actually this method, so that's why we'll define dot and then underscore underscore init method. Okay, and it actually receive actually brand name, so brand, and actually speed from its parent. Okay, it actually receive two things from the parent, and then actually we will additionally add numbers of door by using reference, so self dot numbers of doors, and that would be numbers doors. Okay, finally we'll have another method. For example, you can just check the fuel, so that's why we can simply say fuel available, fuel fuel underscore available, and it will be self, and this method actually simply return uh, something like this: the tank is full. Okay, something like this. We have a parent class, and now we'll have a child class. What the next? Now we'll have to uses this. So for doing this, let me uses, and here we'll create my car by using its actually child class, so my car. And for this we'll have to call the car class from the above, and it will receive three things. Actually, it will receive a brand name, speed, and number of doors. Okay, so my car, I love Toyota, so that's why we will pass Toyota, and then we will have to pass the speed. For example, it's actually 120 kilometer per hour, and this car has two doors. Okay, so for example, this is the thing. Now if I print the method from its parent, though it's actually a class instance of the car, but you can call the method of the parent class. Okay, so for doing this, let me print. Here we'll call the instance my car, and then this is the time we will call the drive method from actually parent. As it's inherits, we can just receive that, so that's why we can simply call the drive method from actually vehicles. Okay, so you can see it's actually inside the vehicle class. Okay, now if I just simply run it, you can see the Toyota is driving at 120 kilometer per hour. The console log is actually the print actually from here. Okay, so I hope you understand this. And now if you call itself own method, then you can also do that. For example, let me print here. Actually, I am just calling its own method, that is actually fuel available, and now it will give the result. Actually the tank is full, so run it, you can see the tank is full. Okay, so this way actually inheritance work. Next, actually we'll have to talk about composition. So for doing this, here let me define part underscore 2 dot py, and in this file actually we are going to talk about composition. Okay, so composition involves designing a class that contains object to the others. For example, we will have two class and we will combine them to get their attribute or methods. Okay, so that means we have separate two class and we will just make a connection in between them. So for doing this, for example, a car has an engine, so that's why at first we'll have to create a engine. And for example, a brand created a engine of for cars, and some brand actually buy the engine from car from actually the brand and just make their own car. Okay, so it's actually sharing something from in between classes. Okay, so we'll have dev in it method underscore underscore, it will have self, and the engine has a horsepower. This is the power of the engine, so this is actually HORS, horse, P POWER. And right now what will have, it will actually reference this horsepower. So self dot HORS, horse, POWER power equal the horsepower it receives. Okay, and this class has a method that is actually a start. The engine should have a start and a stop, so we can simply define a start method here, start start method. It will receive self, and now it can simply return the message actually engine is started. Okay, next we will create another class. This is actually for car, so let me define class and car. Right now we don't inherit it from engine, actually it's a different class. We don't make the connection by using inheritance here. Okay, so the next thing is that here it will have here its own init method. So it will receive self, then the car has a brand, then it has actually speed, and finally it has a power to run the car, so that is actually is HORS, horsepower. Okay, something like this. Next thing is that here we simply introduce this brand and speed by using self dot brand equal brand, and then actually we will have self dot speed, and now we will actually define speed here. Finally, actually this time we will just reference this horsepower by combining with the another class. So for this actually we will simply say self dot engine, and this will came from the above class, that is actually engine class. So engine, and this will actually receive horsepower, so that's why we'll pass the horsepower from here. So that is actually horsepower. Finally, this init method is done, and this car class has another method that is actually drive. Okay, anyone can drive the car, so that's why we will have a method that's actually self, and it will simply return a message the brand is driving on the, that means the car is driving. You will print speed here, and if you want to access the horsepower you will have to do this way. At first you will have to reference the engine, then we will define a dot method to get access the horsepower from the another class. Okay, so this way actually it will work. Finally, the uses is here. We will have the uses is actually, at first we'll make my car, so underscore my car, and here we'll reference, actually we'll create an instance of car, and it will receive actually three things. So again Toyota, then actually we'll have to pass speed, so it's actually maybe 100 kilometer per hour, and here we'll define the power of the engine, that is actually on 50. Okay, something like this. So if you want to now drive the car, how you can do this? For example, to do this we'll call print, and we'll call my car, and then we'll just call this method by using drive. Okay, so call it. So now if you run this, you can see the Toyota is driving 100 kilometer per hour with a 150 hertz engine. Okay, that means you are just combining class by using here. Okay, so it's actually the combination to the above class, and you can just get the horsepower or the engine power from here. Okay, I hope you understand. And now if you want to get access, or if you want to start the engine, so right now this is actually inside it. Okay, so if you want to start the engine, you can do that. For example, print, we will call the instance my car, then we will have to call the engine, and inside this engine we will have a start method. Okay, so that's why the start method here. Okay, finally if you run now, you can see the engine is started. So by using a car instance, we actually get the method from actually the engine method. So this way actually we just combine two classes and do a combination of actions. So actually the comparison is that here on this inheritance, the relation is a it is in relationship and is has a relationship. Actually inheritance tightly coupled between its classes. It's actually, you can see it's tightly coupled, but here it's loosely coupled. It has indifferent existing, okay, existence. Okay, next thing is that the inheritance is actually uses its parent behavior. Look, this child inheritance uses its parents behavior, and here the combination behavior for multiple class. Here this is a different class and it's a different class, and we combined both by using here. Okay, inheritance is actually flexible, less flexible when requirement changes, but this is actually more flexible and capable. Okay, so this is based to use for larger application to actually combine classes. So now we reached to our final destination. That's why in this tutorial actually we're going to build our final project, that is actually a library management system. We will design and implement a library management system using object oriented programming concept, and here we will use inheritance, encapsulation and polymorphism. The feature it's actually containing, we will make book category and actually catalog by using inheritance. Then we will implement a system to borrow books, and here we will use actually encapsulation, and finally we will have book borrowing system and returning system using polymorphism. Okay, so for doing this, how to implement it step by step, I will give you every single step with some ideology and the way to work with large projects. So for this actually, here let me create a new file. So this is actually library management system, so that's why live underscore live system, we are just make this name something like this, system system.py. okay, so it's a Python file, and we're going to implement library management system. Okay, so the core feature of this is actually we will have system to categorize our book, or we just have okay, we just have features something like this, how to borrow book, how to return book and everything. Okay, so let me do it step by step. At the beginning we will have a step 1. okay, so this is the step 1, and here we will define a book class. Okay, so let me comment define a book class. Okay, so for doing this, as you already know, we will have to start with class, and then we will define the class name, that is actually book. Then we will have a initial state, and that is actually a method, that is actually dev init method. Okay, init method. Using this init method, we can just initialize some actually attributes or values, something like that. Okay, so here we'll by default receive self, and then this book has a title, we will have author name, so that's why author. Then the book, each book has an unique identifier, that is actually ISBN number. Okay, so then it actually reference this title, author, ISBN, and availability check. So that's why we'll simply define self dot title, and that will be the title we will receive from the above. Then we will have self dot author, AU TAs or author, and we will reference the author it actually receives as a parameter. Finally, we will have self dot ISBN, this is the unique number, and we'll reference it with ISBN. And finally, we'll check the availability status. So that's why we will simply define self dot avail avail bill status underscore status, and that would be by default true. That means this is actually available right now. Okay, this is the initial definition, okay, of the book. And now if you want to get the book details, how you can do, for example, we can create a function that is actually method in actually class. So get underscore details, or you can just define book details, it's up to you, it will actually save. And right now we will simply return a dynamic string that is actually f. Here the title will be, so to define curly braces we'll have save dot title, then we will add a comma, we will define author, the author will be curly braces save dot author, you can see it's suggesting. Then we will print actually ISBN. Okay, so that would be curly braces save dot ISBN. Okay, so if you call this method, actually it will return this string. Okay, fine. Then we will mark borrowed book. Okay, so for doing this we will have another method, so that would be, so mark underscore borrowed, borrowed, and that would be self. And now it actually defines self dot available status, will make the status actually false. And finally, if the book is returned, that means the book is available again. So that's why mark underscore return. Okay, and this will receive self, and will make the attributes, actually these attributes actually true again. Okay, so for doing this self dot availability status, that is actually true. So this way actually we create a class for actually book, and now we will test it. So for doing test here, how to do that, for example, let me add a comment, testing books. Okay, so let me create a book that is actually book, and we'll call the class. And now this is actually the instance of the book class, and here we'll have to pass three things. So first one will be book title. So let me define the book title, the great book. And for now actually you can just define the writer name. For example, I wrote this book, and I'm just joking, and the ISBN number is actually 12345. Okay, something like this. Okay, to get the details of the book, how to do that, you can simply print, and here book, and you can simply call the methods get details. So now if you run your code, to run this actually we will have to choose Python file, and then the title, the grade book, the author is Mamun, and the ISBN number is here. That means our class is working, and here this is actually class, and we define the instance of the class here. Okay, finally now we will have to move to the second step. In this section actually we're going to create categories. So either we will have a fiction class or non-fiction class, and we will do it using actual inheritance. So that's why here we will define step 2. We will just define create categories class, category class for actually fiction, shown or non-fiction. Okay, non-fiction. Okay, so here actually we'll use inheritance, okay, of the book. So for doing this, here let me define a child class that is actually fiction, and it will receive the book class. So as it's the child class of the book, so that's why we'll pass book from here, actually book. And now we inherit some characteristic of the book, for example this characteristic. And for this, actually at the beginning we will have dev underscore underscore init. It's very common in actual object oriented programming. It actually receives self, then it has actually title, author, then ISBN, then we will just pass another parameter that is actually genre. Okay, genre. And for this right now, if you want to just use the attributes from its parent or method from its parent, you will have to use super method. So using super method, we can access attribute or class, or class attribute or method from actually parent. So this actually call this book to just get access their methods. Okay, so for doing this, actually here we'll call init method. So from here, and it will actually inheritance all of these stuff. So it will actually inheritance all of these stuff. So author, title, and ISBN, we just copy the characteristics from the parents of the genre. Okay, so by using this, actually we'll copy all of this stuff from a book class. Okay, next thing is that we'll have to define the genre. So that's why self.genre equal genre. So that means we are getting all of this information from actually the parent class, and for the child class actually we define this. Okay, this way actually we are just creating a categories for actually fiction. Now we will create another subclass that is actually for non-fiction. So that is actually non-fiction. So this will also be the same as actually book. Okay, it will just define book, and for this actually we'll have dev underscore underscore in it underscore underscore, and here actually we'll have same, it will have self, then it will have title, then it will have author, then ISBN, then additionally it will have a topic. Okay, so for doing this, actually we will get access title, author, and ISBN from actually parents. So that's why we'll use super method, and then we'll call actually underscore underscore init method, and we will receive actually, look, it's suggesting we'll have title, author, and ISBN. So it's already suggesting. Okay, title, then author, then actually we'll have ISBN. Okay, this will come from actually the parent, and now we will reference that topic. So that's why save dot topic. Okay, the topic will be the topic we receive. Okay, topic. Okay, something like this. So this way actually we will have two child class. These are child class, and here actually we use inheritance. We inherit some characteristics from their parent. Okay, from their parent. And now let's test it. So for doing this, for actually let me comment test inheritance. Okay, something like this. So for example here, let me make a instance for fiction book. Okay, so fiction underscore book. Okay, so right now we'll call this fiction class. So that's why fiction class, and this will actually receive four items. Actually it will receive title, author, ISBN, and additionally it will receive genre. For example, the book title is 1984, and then we will have to pass the writer name, that is actually George, Georg, George Orwell. Okay, then actually we will have to define the ISBN number, that is actually something like this, and finally we will define a genre, that is actually dys to pan. Okay, something like this. So now if you actually print this, for example, print fiction book, and call the methods from the above, actually get details method from the book. So we'll call get details method from book. What output it will give you? So let me run this. You can see the title, 1984, the author and the ISBN. Okay, you are getting this output. And for actually non-fiction book, you can do the same. So for non-fiction book, let me define non-fiction underscore book, and for now we'll call non-fiction class, and it will receive actually book name, for example, Sapiens, Sapiens, Sapiens. Then the writer will be Yuval Noah, something like this, RRE. Okay, something like this. Then we will have the ISBN number, that is actually 22, and this is actually the topic of history, so we will define history. Okay, now if you run the book details, actually what output you will get, you can simply get an output. So that's why let me print non-fiction get book details, and if you call, you can see title, Sapiens, author, and ISBN number is printed here. Okay, so we have completed two steps. Next actually we will work with encapsulation. So for doing this, actually let me define another step, that is actually step 3, and now we'll create a class for actually borrower. Okay, so define a class for borrower, borrower, and here actually we will use encapsulation. Okay, capsulation. Okay, so for doing this, actually let me do it. We'll have a class that is actually borrower, 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 and then actually it will have a definition, that is actually init method underscore, and this time actually it will receive self, it will have borrower ID. So person who borrowed, we will have to store the ID of it, so borrower underscore ID. Then we will have the name of the person, will have email, and finally we'll have the phone number. Okay, so this time actually we'll have to use the references, so that's why self dot, we can simply define borrower ID equal borrower underscore ID. Then we will have self dot actually name, that will be the name. Then we will have self dot email, and that will be email. And finally we will have to reference the phone number, so that's why self dot phone, and we can simply define the phone number. And now we'll actually use underscore here actually, so because we want to make it private, so that's why we will define underscore. So underscore to make it actually private. Okay, this is actually private properties, general people cannot get access of it, so that's why we'll make underscore to make it private. And now additionally here we will just track the borrowed book, so that's why we will define a list of the borrowed books. So we'll define self dot brow borrowed underscore books, and here will be a list. Okay, so this is actually tracked borrowed books. So next thing is that we'll have to define another method, that is actually get borrower's book details. So get underscore borrow borrower details. Okay, details, and this will actually self, and here actually we can simply return multiple things. So that's why we'll have curly braces. We'll just return an id, and the id will be so self dot underscore so borrower id. Then we will have a comma. We will just define the name of the person. So that's why name, the name will be self dot underscore name, and then we will have email, phone number, and borrowed. Okay, we just keep to the phone number. Okay, something like this. And now another thing we will do is actually we can just define another method to get. So here actually we'll have another method, that is actually dave, and we can simply update the borrowed books details. Okay, so update underscore borrower details. Okay, so here actually it will receive self, then it will have the name. By default that would be none. Then we'll simply define email. By default this will be none, and finally phone, that will be by default none. Okay, so none means no value here. Finally here actually we'll check if name. So then we'll simply define self dot underscore name, and we'll reference the name it just received. Otherwise if email, if has email, we'll check. So we'll just replace self dot underscore email to the email. Okay, and finally we'll check if phone number has, we can just reference it self dot underscore phone. Okay, equals phone. So now let's test the borrower object. So for doing this, here actually let me test it. So for doing this, test actually borrower object. Okay, so for doing this, here let me create borrower, and for now actually we'll call borrower class, and here we'll have to pass actually id number, name, phone number. Okay, so id will be for example 1, then we will pass a name, that is actually Alice, then we will have actually an email, that is actually alice@gmail.com, something like this. Okay, next thing is that it will actually receive a phone. So phone will be, or we can just simply define a phone number 12345678990. Okay, something like this. Okay, fine. Now if you just print the borrower details by using actually borrower dot get borrower details, if you call this method, what output you will get? You will actually return this. Okay, it will actually return this. So let me run it. You can see you will get an id, a name, email, and all of this stuff in a dictionaries. Okay, so this is actually a dictionaries data type. The next thing is that what about the updated? If you pass name or email or phone, it will actually update this information. So for doing this, let me update it. So for example, I'm just writing borrower dot, will call the method actually update borrower details, and here we'll simply pass the email will be, so next email, so that is actually alice at the rate now hotmail. Okay, hotmail.com. So we just updated the email of the alice. So now if you just print it, so print borrower details, then run it, you can see now id is okay, name is okay, but the email is now updated. You can see that the previous one was actually gmail.com and now it's actually hotmail.com. The phone number is still the same. That means we're just updating the borrower details. So this is actually user management. The next thing is actually we'll have to create a library. Okay, so it's actually the last step. We'll have to create a library. So let me comment step 4, that is actually create a library class. Okay, so it's actually help you to handle book borrowing, returning and fine calculation. Okay, so for doing this actually we will have class, and that is actually library, and this time actually we'll define div, we'll have init method here, underscore underscore, it will receive self, and simply it will actually define self dot books, and we will define a list here, and we will have self dot borrowers. So by default borrowers borrowers, that will be a empty list. So by default we will have two empty lists, one is for book and one is for borrower. When we will add a new book, we will actually append something to this list, and when we will have a new borrower, we will append it. Okay, so for doing these two method actually we will have new book, so that's why add underscore book method. Actually here it will have self, and then we'll have the information of the book inside book actually. So here actually we will append the book. Okay, self dot books dot append, and here actually we'll pass the book information. So this is the book information. Then we'll have another method for actually add borrowers. So self add underscore borrower, and here actually we will have self and borrower borrower. Okay, so this will be the same, self dot borrowers dot actually append, and we will pass borrower, okay, information here. So after doing this, what the next actually we'll have to define borrower book section and return book section. Okay, and then finally we will calculate this. So the next method will be div, and here will be borrow book system. So book system, and this will actually receive self, and we will pass borrower information and book information inside it. And then actually if we'll check if book dot available status, so available status, avail avail availability underscore status. Let me check the spelling, maybe that is actually availability status. Let me copy it, and if book dot availability status, then actually we can simply say book dot mark underscore borrowed. Okay, and we'll call this. Then we'll simply define borrower dot borrowed books, and then append the book, and finally we'll return a message: you successfully borrowed the book written by this something like this. Otherwise you can simply define a else method that will be actually will simply return book title is currently not available at this moment. Now we'll have to make a function for actually return book, so that would be def so return underscore book, and this will actually receive self, and it will have borrower, then will have actually book, will have days underscore due over div, actually days over due, and that would be 0. Then by default is underscore member, and we'll define false. Okay, something like this. And here actually we will check, so we'll check actually if book in actually borrower dot borrowed books, BORROWA borrowed underscore books, and here actually we can simply define book dot mark underscore returned. Okay, and finally what we'll do, we'll make borrower dot borrowed books and remove books, and finally we'll have a fine calculation, that is actually so self dot calculate underscore fine. Okay, the fine will be is member, and that would be days, actually days overdue. And finally we'll simply print, so what we will print, we can simply print f, and here we'll say so book dot title has been returned, and fine is actually we will have to define dollar sign, and here actually we'll pass fine, and we'll just do it on 2 decimal points, so that's why to f. Okay, something like this. Okay, otherwise we'll have a else block, so we'll have else, and that will be we can simply print the book is not borrowed by this borrower. Okay, BORROWER borrower. So let me close it. Okay, so next thing is that we'll have to define a calculate method. Okay, that used actually here, calculate fine. So that's why we will have def, let me make this method here, so calculate fine, and this will actually receive self, then it will have is underscore member and over days. So we can simply pass all of these parameters here, and next actually we will calculate the rate. That rate is actually will define 0.50 if is member, else actually it will be on dollar. Okay, something like this, and simply return actually days overdue into rate. Okay, finally actually we have done this, and now we'll actually test it. So for doing this, actually let me comment test library. Okay, test library, BRARE functionality. Okay, functionality. Okay, so for doing this we'll have to create an object that is actually ly BAR BA BRARY, actually library, that will call the library. And now we'll add some books, so let me add books. Okay, so for doing this let me add book 1, and for this actually we'll call fiction. And here we can just define fiction 1, and for now actually we'll define writer. So this is Mamun. Then we will have to define actually ISBN number 1596, something like this. And now we'll have a genre that is actually drama. Okay, something like this. Then we'll actually call this. Okay, we'll just copy this by doing this. Let me copy this, and for now actually we'll paste this will be book 2, and we'll define that is actually non-fiction. Okay, 1, that will be max. Okay, has been number will be something like this, and it will be actually history. Okay, something like this. Finally, what you will do after doing this, we'll call library. Then we will define add book, and we'll simply pass book 1 inside it. Okay, next thing is that we'll have to add the book 2, and finally the step 3 is add borrower. So for doing this we will simply define borrower 1, and we will have to call borrower, and this will actually receive, so it will receive an ID. So the ID will be, for example, 5. Then we will define the name, that would be so what soon. Then we will simply pass actually watson@gmail.com. Then it will receive actually phone. So phone will be something like this, 0 1 2 3 4 5 6 7. Okay, something like this. Okay, we are just do a separator here, so something like this. Now we will add this to the library, so that's why we will append it to the library. So we'll define library call add borrower, and now we'll pass the borrower 1. Okay, so borrower 1 inside the library. And finally we will give actually borrow book system. So borrow books. So for doing this we will have to call library. Then we will have to define borrow book method, and this method will receive actually so borrower 1, and its second parameter is book 1. Okay, so book 1. So this is the on. Now we'll simply define so return of the book with find. So return books with find. Okay, so for doing this actually we'll have library dot return book, and here actually return book will receive borrower. So we'll pass borrower 1, then we'll pass the book, that is actually book 1. Then we'll simply define actually days overdue. So days overdue, that is actually 3, and then we will have to pass is membered, that is actually true. Okay, true. And then the next thing is that if you now next thing is that you can just check with non-members, so borrower non-available books or non-members another book. Okay, so that is actually, let me create borrower 2 actually, and that would be, we'll call actually borrower method, and it will actually 2, then we'll define a comma, so we can just define it 10 id, then it will be Bob. Okay, finally it will have an example, that is actually bob@gmail.com. okay, finally it will have a phone number, that is actually 89062 something like this. Okay, so next thing is that, let me add it to borrower, so library.add borrower2, and additionally we'll define a borrow book system, and now it will define actually return book system, so library dot return book, and it will actually pass borrower2, then it will return the book 2, then we will have days overdue, that is actually 5 days, and finally is member, and the result will be now false. Okay, false. Finally, if you run this, let me check book print book details, we are just doing all of these stuff. Okay, fine, let me check everything is okay. Now if we run this code, you will see actually those printed. Actually look, the book id is 1 and the book Alice, all of this stuff is okay. The fiction 1 has been returned it, and the fine is actually 1.50, that is actually calculating from here, so returned book with fine. Okay, as this is actually member, so that's why the amount is less, and the second non-fiction book on has been returned it with the fine $5, because the overdue, if you are not a member, actually if you are not a member, you will have to look, if member, then actually the return amount is actually 0.5, but if not, it's actually 1. So here the borrower 2 is actually not a member, so that's why the due is 5, and it's actually multiplied with $1, and it's actually total $5. If you define actually 10 days due, then if you run your code again, it will say the return value is actually $10. So these are actually, we will implement library management system. I hope if you don't understand it properly, you should have to just practice is twice or thrice time, and then I hope you catch these. Okay, so thank you for watching this tutorial series.